Good day, my name is Rolando Emmanuel, and I'll be doing the presentation along with my fellow group members, Ada Ramgulan, Christian Arjun, Rossi Prasad. For the experimental method in which we use to find the accuracy of the trebuchet, we utilize systematic experimental method where we conducted an experiment 5 times, each time adjusting the steps to 10 different angles. This meticulous approach was designed to ensure the collection of robust and diverse data by systematically exploring variations in the orientation of our experiment by setup. By repeating the experiment multiple times at each angle, we aim to capture any potential variations or patterns in our results, thereby bolstering the reliability and validity of our findings. This methodologic region enables us to thoroughly investigate the phenomenon under the study and gain a comprehensive understanding of any relationships between the variables. The deliberate variation of angles allowed for a analysis of the experimental outcomes, enriching the in-depth insight derived from our research endeavors. Now we're talking about how the trebuchet was built. We first started off by building a base, which was 12 by 18 inches wide and long. Then we did the two arms, which was 12 inches from the top of the base to the end. We then proceeded to build the swing arm and the counterweights and the drop arm for the counterweights. Once this was done, we drilled the holes into the arms, thus allowing a metal rod to be able to pass through. And then we place PVC between the two rods, enabling us to keep it centered. At each end of the PVC, we added two flat washers in which we use this to enable us to reduce the friction, and we had also added grease to the between the two washers to remove the friction. I will now like to hand you over to Christian and Adel.
Hello, good day. My name is Adel Ramgulam, and in this project, we were asked to construct a miniature trebuchet using simple materials such as wood, string, and a counterweight. I will be introducing the equation used to derive the value for distance and velocity for the projectile. For velocity, we combine both kinetic energy and potential energy to derive the equation. We use the values mass of projectile mt is equal to 0.0164 kilograms. Mass of counterweight mc, which was 1 kilogram, drop weight height h, which is 0.050 meters, and gravitational acceleration due to gravity, which was 9.81 meters squared. Hence, we found the value for v, which was 2 by mc by g by h over mass of projectile. We then used the previously found equation to derive an equation for distance, which was found out to be phi squared sine 2 theta over g. The variant factor theta, which is the manipulating variable, can now be inputted to find the distance, which would then be converted to meters. I will now hand you over to my colleague Christian Arjun to explain the derivation of the mathematical model.
Hi, good day. My name is Christian Arjun, and I'll be speaking on the mathematical model that was derived from our project or Minature trebuchet. So to begin, the mathematical model was found to be L1 k theta is equal to mx double dot by L2, m being the mass, L1 being the moments with respect to the projectile or the ball, L2 the moments with respect to the counterweight, and k, which is the torsion or the pivot point at which the counterweight. To derive the transfer function is the output Laplace over the input Laplace, which gives us x of s, which is the distance, over theta of s, which is the input. Taking Laplace of initial conditions with respect to 0 gave us L1 k theta s is equal to ms squared x of s L2. This then led us to the transfer function being x of s over theta s is equal to L1k all squared all over ms squared all squared by L1, L2. We then moved on to speak on a step transfer function. The step transfer function, we inputted theta to be 30 degrees. From the previous equation, x of s over theta of s gave us x of s over 30 over s is equal to L1k squared all over ms all squared L1, L2. X of s is now equal to 30 by L1k all squared all over m squared s to the power of 5 L1, L2. Now find the time constant. In the end, the time constant was given as 30 L1 k squared all over m squared by L2 by t to the power of 4. I will now hand you over to my other colleague who will be speaking more.
Good day. My name is Rossi Prasad, and I will be discussing our theory versus our experimental results. In our theory and our mathematical modeling, we did not take into account the real-world conditions due to the simplification of our calculations. The factors that we neglected that may have affected our trebuchet are the resistance, friction of the materials, or even the material imperfections. There were also some limitations with our precision in cutting tools and or human error in the data collection. Although we achieved our desired outcome, there were some range in our distance and differences between our theory and our experimental results. The counterweight mass of our trebuchet held a constant 1 kilogram. This was used as our constant. However, the variable factor was the angle. And so, to change the distance of our trebuchet, we would have to change the angle. There were 6 angles used in this experiment. These angles were 10 degrees, 20 degrees, 50 degrees, 40 degrees, 50 degrees, and 60 degrees. For these 6 angles, 3 tests each were conducted, and the average of the 3 was found. Improving the differences between the theory and experimental procedure, for the theoretical calculation, as seen on table 1 at 20 degrees, we had the calculated value of 110 centimeters. However, in our experimental value at 20 degrees, we had 141 centimeters. And so we had a difference of 40 centimeters. This was also seen at 40 degrees, where our theory had 221, whereas our experimental results had 252, respectively. This gave us a difference also of 30 centimeters. This build is our final design. It has previously gone a trebuchet design of a traditional trebuchet, where there's a sling involved. Due to our real-world conditions of precision and play, the sling was switched with a throw-up. This has given us more accurate results, as the sling gave us a more sporadic outcome.